All right, I think we've got most people here. There's a few people still trickling in, so we'll get started maybe just with the housekeeping items this morning. Say good morning to everybody. Thank you all for joining us today. It's the Combustible Dust Explosions webinar. I'm Jennifer Johnson, Stakeholder Relations Coordinator with the Safety Codes Council, and we'll just go through a couple of small housekeeping items. We are recording today's presentation for use on our website, so there were people. I'm working from home. I apologize for my dog. We are recording the presentation for use on our website, so we did have to turn people away. These are always very popular. So if any of your colleagues missed out, you can let them know. We will have it available on our website in a couple of weeks. And when you watch it on the website, you can still self-report for the continuing education credits. So I know that's a question lots of people have, and it still does count towards them. Our presenter today is Francis Petit. He is a dust collection and design specialist, and we are very excited to have him here today to teach us a few things. We will have everybody mute just to make sure we have no background noise once we get started, and probably turn your cameras off as well, just so that you're aware with the recording, everything does show up on that. Afterwards, we will do a short survey. You'll get it in your emails probably later this afternoon. Feel free to pass along any feedback you have on the webinar, the registration process, all of those things. We're always looking to improve as we do present these multiple times a year. To report yourself, to self-report your continuing education credits, you go on to Council Connect. You are able to do it through there. You will get 3 for today's presentation. If you have any difficulties with that, figuring out how to do it, you can reach out to our certification team. They are always happy to help out and answer any questions that you may have about that. So we will also be taking questions at the end. Francis's presentation is about 40 minutes long, so there will be time for questions. And if you just want to pop them in the chat feature at the end, we'll get through them all as best we can. So thank you all so much for attending, and I will pass it over to Francis now. Thank you so much.
All right, a special thanks to Jennifer for putting that together, and the Safety Council for having us over for the webinar. And I hope it's going to be interactive, and like to answer any questions if you have any at the end. It'll be my pleasure. And like Jennifer was saying, just so we have a smooth sail until we get to the end, let's maybe hold on to those questions, and then we'll address them at the end of the presentation. So this webinar, you're probably wondering, okay, what is dust and why is combustible in the same sentence and dust. The idea behind this training is to give you awareness in relation to the hazard in dust collection and combustible dust. By any means, you'll be an expert at the end of this presentation. Unfortunately, it takes several years to get some grip and be able to have some momentum, in that field of expertise. But I hope that at least it's an introduction for you guys, and you'll be able to take some takeaway at the end of this presentation. So let's get started. So who am I? I think Jennifer did introduce me a little bit, but I'll give you a bit more of my background. So I'm a professional engineer. I've graduated from the University of Sherbrooke in Quebec. Therefore, my accent, please. Parlez-vous français? I'm sorry, I apologize of my English that is not exactly perfect, but I'll try to do my best there to hide my accent. Okay, so I've been in dust collection for about a decade, a little bit more than a decade, and specializing into dust collection and dust explosion protection. I'm also a member of APEGA, EGBC, the Engineer Order of Quebec, NFPA and ASHRAE, and I'm a dog person as well. So really, I have 2 dogs at home. I couldn't find a good picture of me with my 2 dogs, but that's my kids, so my dog there, the picture. All right, so presentation summary. We'll go first and we'll look at who is VETS, and then we'll dive right into what is a dust collector, followed by industries that requires dust collection. And we'll briefly look at the explosion fire risk, and we will have a case study. I always like to have a case study to show you know, in the real world, what is happening and when things go wrong, and we will answer your questions at the end. So, who is VETS? So, VET was founded in 1921 by a veteran for the World War One. The name of the founder is Fred Rayner. So he was fighting in World War One. He came back. Essentially, he had the idea of starting that business, and he hired a bunch of veterans. Therefore, he decided to name the company VETS, and we kept that uh, heritage. Essentially, we are really involved into veterans in our local community. Sean Rayner, the owner of VETS right now, is doing some great community work for veterans. We are a fourth generation family business as well, so it's rare that we can say that. And you know, 1921, we're officially 100-year-old as of last year. And so it begins in the post-war. The first work that was performed by the company was more residential and furnaces, and it grew into an industrial and commercial HVAC, as well as building maintenance and services. We are geographically covering Western Canada, so we do project in Saskatchewan, Alberta, BC. That is kind of our territory, though we do from time to time project in other location. I'm currently working on a project in Quebec, but it's more so the Western Canada. And our head office is in Edmonton, and we do have an office as well in Surrey, British Columbia. So enough of who's VETS. Let's dive into what is a dust collector. So I'm assuming everybody is a bit familiar with ductwork. I'm not going to lose everybody when I say you know, a ductwork or a hood. But let's go into the component related to a dust collector. So if we looked at a dust collector, it all started by the hood, number one here. And then you do normally have to put balancing damper, we call it, which is essentially a way to calibrate the airflow. So if you had not put in the blast gate in the system, what would happen is air will go to the least path of resistance. So essentially, if you have something that's closer to the collector and the fan, most of the air will go that direction, and then it won't go into the rest of the ductwork. So the first step of a successful dust collector is to have the system balance. And then so number one, as we said, the hood will capture the dust where it's generated, and will introduce it with air to convey it into the collector. So number two is the main duct, we call it, which will eventually go to the dust collector. So what is the dust collector? Essentially, what it is a canister well where the air can expand and slow down, and then there's filters which creates a barrier for the dust. Dust will accumulate on the top of the filter membrane, and the air will be able to penetrate through the filter and essentially go through a fan, and the dust will have another pad. So the dust will drop off into a hopper, into an airlock, and then there's going to be a disposal of some kind for the dust, like a bin of some kind that will deal with dust, or it can be introduced into a pneumatic conveying pipeline, essentially, where you're using air, compressed air, to pump material from point A to point B, essentially. And then the fan, number 5 here, will create that negative pressure for that air to move in the ductwork. And the control and instrumentation is essentially to make sure that you monitor your system, you understand your system, and you're able to control it properly. So I'd like for everyone to do a little bit of something. Don't worry, your camera's not on. So put your hand right in front of you, about a foot away, and try to blow on your hand. You feel something. So more than likely, your answer will be that you do feel something. And then try the other way. Now try to suck into. Do you feel anything? You don't feel anything. The reason being is when you're sucking air through your mouth, your velocity will drop at about 10% of your velocity at your lip. at about one, if you look at the dust collection system. So you've got pipe that, let's say, is 12 inches. So at 1 foot away from that opening, the velocity at that face will be about 10%. So if you imagine, like, if you have dust to capture and you're too far from the opening, then there's just no really successful ways to capture it. And I always, when we do our design and dust collection, we account as well for containment, which is super important. Imagine a saw that's cutting a board. Well, that saw will be spinning quite fast and will generate a lot of dust. And then that dust will be projected pretty much at a high velocity everywhere. So if you don't have a proper hood to capture that dust generated, then imagine like trying to suck from that hood, you might get 10-15% of all that dust generated. So therefore, like, that's why there's different means that are often put on saws to contain, and then you can suck from the saw blade essentially a little higher, but your rate of success to capture the dust is quite higher. So extremely important. The hood design is really, really critical to be successful, as well as the containment. And there's component, it seems simple, but there's component, if it's not selected properly, will create a lot of issues down the road for that system. If you don't have a proper fan that will be able to reach the proper flow and static pressure, you know, you might have the best collector out there in the industry, but it's not going to help you at all. So very important to keep that in mind. Also, another thing that is important is you need to have the proper velocity in your ductwork. If you're going too slow, then what happens is essentially your dust will be settling in the ductwork, as far as we talk about velocity in the ductwork, and that will essentially create a fire hazard in the ductwork, because you have fuel essentially just staying in that ductwork. If there's a spark of some kind, it could blow up. Okay, so that is a kind of neat image of a site where you could find some dust collectors. So if we look at everything that's in blue here, is essentially a dust collector. So you've got different cyclone here, you've got a bag house here, you've got a cartridge dust collector, you got a portable unit here. And you might think, hey, this is probably just, you know, a drawing and it doesn't really happen in the real world. Well, I've actually been to a site where in the same facility, same building, there's over 40 dust collector. So there's some industries like the grain industries, named just that one, where there's so many different dust collected through the plant. It's unbelievable. Flower plants, different things like that, where you've got a lot of dust collectors. This is a bit of a slide that's interesting to give you an idea locally in Alberta, different industries that are focusing essentially on a certain part of the industry, I guess, but that will require dust collection. And I'd like to maybe take a couple seconds, if you guys can put something in the chat, say, hey, you know, this industry, I was not aware that it was essentially dealing with explosive dust or dust at all. Maybe just put your comment in the chat. Like to have a bit of an interactive stuff with COVID not being in person, I guess, but I'd like to have some interaction. If anybody is thinking about another industry in Alberta that requires dust collection that is not written there, please put it in the chat. It'd be great. All right, so let's see if we have something in the chat. I don't see anything. I'll give a couple of seconds there. Animal feed, it's good one. Food processing, absolutely. Yeah, there's many more. A story about, I guess, different part of the industry that requires dust collection. That one's probably a top 5, I would say. So I had someone calling and they were like, hey, we are considering bodies, and we are currently looking at a dust collector to capture the ashes generated. So I was like, okay, well, that's kind of interesting. I've never heard about that before, but hey, dust collector can be used in different industry, I guess. So that was pretty neat. There's a different industry that that you're not just thinking about it, but yes, there's a requirement for dust collection. All right. So this slide shows you the different industries. I'll just let you. So something's happening in the video. I'm not sure what is going on, but we missed the punch. Let's just try again. All right.
4, 3, 2, 1.
There you go. All right. So I hope you didn't drop coffee on your shirt this morning. Sorry about that for the noise and the explosion. But this video is showing about 50 grams of aluminum in a cup when the explosion occurs. So there's not a lot of material, but aluminum is extremely explosive. So if you have clients that are dealing with aluminum that's fine powder or found dust, this could be a very critical and dangerous dust to deal with. So if we look at the different industries and where you can find essentially the explosion and history of explosion per industries. So the food industries is definitely the biggest, where it occupy about 25%, 24%, followed by the wood industry. And then you got chemical. I won't go through every single one, but there's furniture as well. That's pretty high, 8%. Where I know several people just out of Edmonton or Calgary that are operating wood furniture business. So these are all at-risk industries for explosion. Then you just look at the blast for an aluminum dust. It's pretty impressive and it's scary at the same time. So super important to have the proper protection when you deal with explosive dust. So next slide will just show you a bit of an unfortunate incident that happened with our neighbor in British Columbia back in 2012. It was January 20, so just imagine yesterday. It's been 10 years 10 years already. So the Babin Forest Product sawmill in Burns Lake, there was an incident where there was an explosion. So the explosion essentially took off the walls in the building, killed 2 people and injured 19 other ones. So that's very unfortunate. Like, you look at the impact of those people that lost their life. It was an impact to the community. It's a small community out there in Burns Lake. People losing family members and so on. This could have been prevented. Unfortunately, the impact, you can't bring back someone. So they're important to do it properly. And I'll show you the next slide there, where I explain a little bit more in detail why dust can be explosive. Probably everybody know that some dust, like wood, would be flammable. But if we looked at, you probably remember high school seeing that triangle of fire, which requires fuel, oxygen, heat. In a scenario where there's an explosion, you still have the triangle, but you add two different angles to the triangle. So you got dispersion and confinement, which are two added essentially characteristic. So dispersion, when you think about it, you have a dust collector. The air moves with dust. It's more dense, and it expands in the collector. So you got that dispersion, like we call it the dust cloud. So a dust cloud has a potential, because the space between each particulate, there's enough oxygen between to create a violent fireball, essentially. And the confinement is another one. So confinement will, again, in a dust collector or in a building, you're confined. So you have walls where the fireball cannot expand and will just increase the pressure of the envelope or the confinement. So think about if you have a log. So I have a log here, and I'm able to burn it in, let's say, 3-4 hours before that log is completely burnt. Take the same log and cut into small, fine particulate, and then allow that dust to be just pushed into a cloud, the dust cloud, and then use a match or source of ignition, all that energy that you've created in 3 hours is essentially just created in fraction of a second. So you've got that big, huge energy fireball just expanding, which will generate, if it's in an enclosure, will generate a spike of pressure. And the spike of pressure essentially cause an explosion. That's kind of a way to explain it. So codes and standard. So how does it work? Where do we start? There's different codes and standard in the industry. The building and fire codes are definitely in Alberta pointing at a certain standard, which is the National Fire Prevention Association, NFPA, right here. And this is a standard, so it is not a code. Therefore, it's not necessarily legal unless it is endorsed by the building, or the fire code. So both building and fire codes are referring to NFPA as a requirement to follow for best practice. So therefore, NFPA becomes part of the code, even though if it's a standard. So OHS is another one that will also refer to NFPA. You have electrical codes as well. You have the underwriters, so entrants like FM Global, Marsh, that are also part of the authority having jurisdiction, and obviously the National Fire Building Code and Electrical Code. These are all codes and standard that you have to comply to, and most of the information can be found in an NFPA. I don't want to bore you with different NFPA codes, but if you look especially at NFPA 664, which is for wood, NFPA 68 is for explosion panel design, NFPA 69 is all the protection around for the isolation around the dust collector. And then there's 652, 654 as well. These are all great codes to understand if you're dealing with anybody that has explosive dust. So if you go see a client and you see a collector, so there's a first step to know if your dust is explosive or not. And the first step is essentially to collect a sample of dust. Generally, I recommend to collect in a barrel, and you have to send it to a lab, and the lab will essentially characterize the explosibility of the dust. So they'll have a ball where they blow up different concentration of dust and with different igniter, and that will generate essentially enough data to characterize that dust. So there's a few characteristics that are very important in dust collection. The first one would be the KST. What is a KST? So it is how fast the pressure raise when there's an explosion. And typically a KST is between, for wood, let's say it would be from 0 all the way to 200 KST, and it's in bar meters per second, the unit. You have a Pmax. What is a Pmax? So it's the maximum pressure that specific dust will generate in an enclosure. And you have other different characteristics such as the MIE, minimum ignition energy required, and the MEC, minimum explosive concentration that is required for an explosion. So if there is an explosion, you want to make sure that the dust collector is designed properly. So the first thing is you want to make sure that the dust collector have some type of explosion panel. If we look at that slide here, you see there when there's a blast, the explosion get released, the pressure get released of the fireball right where my mouse is circling. So that explosion will like the explosion power will prevent from the dust collector to essentially becoming a bomb and exploding. Because if you don't have those panel, the pressure will spike, and the explosion happens in about 0.2 to 0.3 seconds where it reaches its maximum pressure. So think about wood. Wood is a common thing that we see in the industry, obviously, and that potential for that wood dust to expand in pressure is up to about 110 psi in a matter of a fraction of a second. So can you imagine if you have 110 psi applied on the wall of that dust collector, it would push it into shred. That's why the explosion panels are required. And the explosion panels are similar if you do comparable to your hot water tank at home. So if that hot water tank would get too much pressure, there's a valve that will open automatically to release the pressure. So and so when you think about it, when there's an explosion, the explosion will travel everywhere. It won't care if it's the inlet of the ductwork where you're sucking from the hoods or if it's the outlet. So you need a mean to protect the ductwork so it doesn't go back in the building in a different direction, either taking the inlet, going back to the hoods, or the outlet going back into if you recirculate the air back in the building for energy purpose in the winter. So how does it work? There's different technology, and I'm just showing you one or two. There's many more possible ways to protect your collector, but it's important to understand again your dust, to know how much pressure is generated, so that you can select the proper piece of equipment. And everything that I'm talking about needs to be engineered. It can't just be assumed. So you have to have documentation showing your dust test that you've done, documentation showing the calculation that is required to come up with the vent area, so the amount of area that is required to vent. So if I look at the isolation, so here the explosion can travel back in the ductwork, and it needs to be stopped. And so there's something called a no return valve or backdraft damper. How that works is essentially you have a pressure wave going back in the ductwork, and that pressure wave on normal circumstance, you have just the air and the dust coming this way. So that would be number one here. So there's a gate that's floating, and that dust and air will be able to go into the collector here. And when there's an explosion, there's always if you deal with subsonic explosion, you always have a pressure wave before the flame. So the pressure wave will act first as an impact on that gate here, and will close that gate before the fire and the fireball comes back in the building. Earlier, I was saying to have that proper velocity in the ductwork. The reason being is if you don't have that proper velocity carrying the dust, it will essentially drop dust in the airstream in the ductwork, which is fuel. And so the fire will just feed on the fuel and just get bigger and bigger as it travels back in the building. So the pressure wave will shut your gate close, and there's a locking mechanism. So when the fire comes, it can't go any further. So it gets stopped and essentially can't travel back. So these are a very important piece of equipment to install in your system. This is an abort gate. What is an abort gate? Essentially, there's spark detection that you can have mounted on your ductwork. If there's a spark generated, that spark will be noticing a control panel, and that control panel will activate a fast activating abort gate and will divert the explosion to so that it doesn't get returned back in the building. So looking at different examples, I mean, there's so many things we can talk about how to protect the collector. Again, we're not going to get the expert at the end of this presentation. It's just to give an awareness of things that can be used to protect collectors. So if we looked at this ductwork, I'm not sure if everybody's familiar, but this is spiral tube. It's used a lot in commercial building. You know, if you go to Walmart, look up, you'll look at the ductwork, and everything's made out of spiral tube because it's cheap and it's easier to install. In dust collection, this is not allowed because of several reasons. But if you see a spiral tube in the system, you know, it should be a red flag saying, hey, this collector might not be to code. If you see people working in the shop using compressed air to clean explosive dust, that's another big no-no. The reason being is you create that dust cloud. So if there's a source of ignition, it could blow up the place. It is actually allowed to have a certain pressure of compressed air, but I think it's rated to maximum 20 psi if you use compressed air in the NFPA, I believe 664. If you look again at that picture, any fuel in the building will create that potential for an explosion. In NFPA 664, which is for wood, it is allowed to have up to 5% of the surface being covered at 1/8 of an inch. If you're above that, then your area become classified electrically. So it requires additional protection for your, group 20 in the electrical code, which, it is explosive. So you want to make sure that when you look at the place that they are doing their proper maintenance, and essentially cleaning the floors, cleaning the cable trays. 5%, 1/8 of an inch is not a lot. So if you have cable trays that have a little bit of dust, or trust, or anything like that, well, this could be sufficient to create a hazard in a shop where, the explosion would actually cause severe damage. So let's look at a case study. A case study that happened actually not too far from Edmonton, and unfortunately, it was an incident that was actually that caused a lot of issues. It was to give you context of what happened. So it's a carpentry shop where they fabricate high-end commercial furniture. They grew into from a small shop to a larger shop where they had several different pieces of equipment such as CNC, miter saw, bandsaw, router, beam saw, and they had also dust collectors installed. And there was an incident that happened, and kind of wondering if someone can put in the chat what do you think was the cause of the source of ignition. We talked about the Pentagon where we had different piece of the puzzle to have an explosion. So, which piece of equipment create the source of ignition? I'll wait for a couple seconds there. Maybe if you want to write in chat, do you think it's the router that did that, the beam saw, the bandsaw, the miter saw, or the CNC? I'd like for you guys to guess. I'll give you 5 seconds. All right. So, all right. So I see CNC, I see router, I see beam saw. These are great potential here. So the lucky winner is actually the CNC. So what happened is the CNC was cutting and then they missed a nail, and it hit the nail, it sparked, and the dust collector was collecting essentially the dust. The ductwork was actually the mean where the source of ignition got introduced in the ductwork, going to the collector, and that collected. Luckily for the client, I mean, in the bad luck, but they had emptied the drum on the bottom of the collector, so they had limited fuel, but the impact was major. So what happened is the filter were plugged, so they caught on fire. Because they were plugged, they were not creating a dust cloud, which is in a way a good thing for them because they would have blown up. That collector was not protected properly. There's no explosion panels. There's no protection, isolation of any kind. It was indoor, which is a big one. If you have a collector that's indoor, doesn't have the proper protection, even if it's vented indoor to indoor, it is extremely dangerous because it could cause a secondary explosion. The first explosion would generate in the collector, causing a fireball. That fireball would travel in the building, and then the first shock wave, essentially what they would do is it would shake the building, and all the truss and all the cable tray that has dust will create that dust cloud, and then the secondary explosion, like we see in the beam, will basically explode the building, where walls can collapse, equipment can fall. It's not pretty. To come back to this case study, so what happened is there was a fire. So the firefighters came in and they put out the fire with lots of water, but having the collector indoor causes essentially the bunch of the equipment or surrounding to be flooded with water. So electrical component and an edge bender or a beam saw was ruined and damaged, and it needed to be replaced. So if you look at the impact on the different parties involved in that, so client, obviously a huge downtime. They can't produce anymore. All their equipments are not functioning. The building also has some issues, so they have to have people over to clean, to to take care of the situation. So there's a huge downtime, huge loss of production, and not to mention that they were lucky on that one, but they could have had the people being burned or people put the hospital, even worse, fatality in that building. And there was also a huge cost impact on all that from the client's perspective. People losing their job temporary until they can get back to work. Insurance impacts, so substantial and claim impact. You think about it, like all the damage caused by the different equipment, that's huge. So there's negotiation as well with the client. So we replacing like for that collector? No, you can't do that because there's still a high risk. So why would an insurance insure someone that has a high risk? So the cost of the collector is significantly higher when you do it right. So that was a cost impact, and there's a ton of staff involved in the negotiation for back and forth for that scenario there. So from the client and from the insurance as well. Firefighters, think about it, they did put their life at risk, and some of the firefighters, they for explosion environment, it's tricky because if you use water, sometimes you can generate that dust cloud by just pulverizing that dust when it hits. So challenging for them, to use the right method on cleaning, and they're putting their life at risk. So let's look at the next slide. Essentially, that would wrap up my presentation. Again, thank you. You guys were great. I want to open up a little bit at the end on another topic, which is a dust hazard assessment. Do you know actually that as of September 7, 2020, a dust hazard assessment is required as per the NFPA 652 standard? What is the dust hazard assessment? The simple version is that you need to segment each piece of the equipment, including dust collector or different equipment, and to answer 3 questions. So is there a risk for fire? Is there a risk of for an explosion? And is there a credible source of ignition? It's definitely more complicated than that, but this is kind of the bare bone of a dust hazard assessment. And you need to identify the risk. If the risk is too high, or if you're not compliant to the NFPA standard, then you have to do some fix to make sure that you can deal with that risk. And I always say, be proactive. Don't wait for something to happen. I know there's costs related to improving dust collector, making your dust collector code compliant. But a phased approach is always a good thing to do. So, you can't necessarily ditch several $100,000 into upgrades and right away. But if you take a phased approach where you say, hey, this year, this is the highest risk we have, and let's address X. And then in 1 year, we'll address Y. And then the following year, we'll address Z. And after a few years, then you'll be able to have a compliant system, essentially. So that'd be the end. I do have my information here. If you want to reach out to me, call me or email me. I'll be happy to answer any questions related to combustible dust. But thanks everybody for attending. I see there's a couple of questions, I believe.
Yeah, we've got our first question in the chat from Robert. He's wondering who is qualified to complete a DHA and what documentation can we look for to ensure compliance?
All right, so it's a great question, actually. It's a pretty big question, a bold question. I like that. So who's qualified? Normally, I recommend clients to look for consulting companies. I mean, there's several good companies out there. We do DHAs as well, but to have some engineer that has some experience, I would say maybe 5 years at least of experience in the combustible dust, and has some good also reference to handle that. And then the documentation, there's a several document that is important to have, like I was mentioning. the dust test. Did they do the dust test? That's the first one, knowing your dust. And then looking at, okay, after that, okay, do they have the documentation saying it was designed properly for their dust collector? Do they have the proper isolation? And you go to the list. Is there, I didn't mention that, but in the ductwork, there's a risk for static discharge. So do they have a bond between each joint of the dust collector to make sure that there's static dissipation? These are all questions that you have to go and say, well, yeah, no, this is good, or this is lacking. Okay, well, we need to address that. And so there's a process, but I'd be happy if you have a specific Robert project if you want to contact me directly. I can help you out to give you some advice on that specific project. Okay, there's another question, I believe.
Yeah, Bryce is asking, I think he's clarifying that one, a building safety codes officer certified in group B level 3 or higher.
Yes, that is definitely someone that has the competency for sure to perform a dust hazard assessment. And a dust hazard assessment, I did focus a lot on dust collection, but it's more than that as well. You have all the electrical component. So if you're dealing with a certain process, well, if it's deemed hazardous, so you have to look at the electrical component. Are they to code or not? And can you actually keep the dust at a level where it is non-explosive for the environment? So you can classify differently if you can manage your dust level and the fuel. It's all about fuel. If you don't have fuel, or if you have not enough fuel to generate a high risk, you're winning. If you have too much fuel, then you have to handle the process a bit different. Any other question there?
A question from Paul Chang, wondering when we can actually do in-person meetings. Will vets be looking at putting on a full training session on this?
We do offer a 1-day training that we go definitely in depth in the dust collection world. I'm passionate with dust collection. I think it's a great field of expertise. And there's I mean, growing up, I was very intrigued by explosion. I even in my backyard, unfortunately, I did try a couple things there. Fortunately, I kept all my fingers, but we can definitely give more information. There's a 1-day training. Essentially, we could do 2 days. I mean, like I said, it takes years to come up with the expertise necessary, but at least have a better grip on different codes and standard and what can and can't be done. That's something we can discuss later with maybe you, Jennifer, with Aaron, our marketing. For sure, we're open to that. I believe there's another question.
Yep, we have one from Don Rush. What are the warning signs for inspections, testing, and maintenance? Are there warning lights and such for spark sensing systems?
There is actually a control panel for the spark detection. Absolutely. There's different name out there. There's FlameX, there's Graycon, Firefly. These are all names that are manufacturing of spark detection. But most of them do have a control panel where you can see if there was a spark. And if there's a spark, what it will trigger is it's less than 0.5 seconds, so 500 millisecond. There's going to be that abort gate being generated and slam shut, so that if there's a dust or explosion coming back to the building, that abort will divert that flame and explosion out of the building. So that's one way. There's another way also combining spark detection with sprinkler system. So as the spark detect, so it travels, and then there's a sprinkler nozzle a certain distance away where you know how fast the air is traveling, so you know where to put that sprinkler, and it's important to put it in a specific location. And that sprinkler will just sprinkler the water on the spark to put it off, essentially. So that's 2 ways. So aborting, or you can sprinkler that spark. Not a problem, Don. All right. Any other question?
Looks like it so far. Oh, there we go. In food dust DHA, what are the testing requirements and timing? Annual hazard assessments required or at the time of installation? That one's from Fred Nash.
Great question, Fred. So there is definitely in an FPA standard different requirement for inspection and testing. If I didn't really speak about that one, but if you have chemical isolation, essentially what they do is they use a bottle of chemical to put off an explosion. And these are quarterly. Normally, every 3 months, you have to put out an inspection. And normally, the inspection comes from the manufacturing company that does the chemical isolation. If you're looking at explosion panel, I believe it's once a year minimum. So you need to have a document recertifying the explosion panel. The reason being is if the explosion panel doesn't open, you know how critical it is. So it could create a bomb inside the dust collector. So these are annually at least. And then there's other component that are also required to be, let's say, every 6 months or every year to be recertified. Same as a fire system, same idea there. There's a repeated recertification to make sure that everything's to code.
Sounds good. One from Sean asking, are there limits on when a dust collection system can be installed inside a building?
So a dust collector can be installed inside of a building, absolutely, as long as it has the proper protection. It's designed according to codes and standard. But it is very challenging to have a collector indoor, and it is very costly because the amount of protection required indoor versus outdoor, you might looking at the double of the cost to have an indoor versus outdoor for the additional protections required. But there's different technology like chemical isolation, like I said, that can be used for explosion, to put out an explosion. There's also explosion ventless, flame ventless explosion panel, which basically dissipate the explosion as it come out of the opening, and it's just the pressure at the end. All right. Is there? I'm hopefully I answered that question there. See, there's a couple of the ones. I have a hard time to keep with all the questions. There maybe Jennifer, you can chime in and help me out there.
I think we're good so far. Paul's, I think, providing some resources for people on the question.
Okay, there. Perfect.
And Sean says thank you. So I think you
Great.
answered it. Does anybody else have any questions? We have a couple more minutes if anybody does. You're just so good at it, Francis. You answered everything.
Yeah, I'm sure there's going to be a lot of questions, guys. Yeah, it's a pretty big topic. You're welcome, Fred.
Excellent. Well, thank you so much for the presentation. I think it was wonderful. Everybody got a lot out of it. As I said, we will have the recording available on our website in a couple of weeks. There's a whole bunch of webinars on there if you want to go visit our library. And this one will be up there usually within 2 weeks. We have it available on our website. So thank you so much to everybody who attended. And thank you so much, Francis, for a great presentation.
Hey, thanks, Jennifer, and everyone. You guys were great. All right. Enjoy the weekend.
Awesome. Have a great day.
All right.